So, so first of all, what we're going to do is this. We need addition, subtraction, trig formulas. We need unit circle answers, okay? Let's just put down unit circle answers, all right? So Marie asked me, gosh, Mr. Davies, do we need a calculator? And I said, no, we could push it in. We could get the decimal equivalent of cosine of 75, okay? We could just go, what is cosine of 75? That's not what we're after, okay? So on a test, let's say you go, okay, gosh, I can do this. Yeah. Say, gosh, this is an easy question, right? Cosine 75, boom, there's the answer. I'll mark it wrong. And then you'll see, but it's right, Mr. Davis, but it's wrong because it's not exact. So how do we get the exact answer? It's not that hard, though. So cosine of 75, before we do anything, it's addition and subtraction, right? So if I take a look at 75, now I want unit circle answers, right? I really do. So if I look at the unit circle, I'm saying, okay, well, how, with all of these angles, how can I make 75? With all of these angles, because that's what I have to use in the circle, how can I make 75 with all of these angles? Well, how about 45 plus 30? Do you agree with that? So we need to use unit circle angles. So how about 45, 30? Because 45 plus 30 makes 75. Okay, so when you start to do these, you have to say, okay, how can I make that number using angles from the circle? Okay, because once we use the angles from the circle, we actually have some answers, right? We have the unit circle answers. So right at the bat, when I take a look at cosine of 75, I'm like thinking 75, okay? So I would, off the side, 75. Well, let's see. How about 45 plus 30? You guys okay with that? 45 plus 30. That's one way. There are other ways to make it. There really are. You could probably go, gosh, let's see, go 120 minus maybe 45. There's lots of different ways to make it, but this is probably the easiest. So you can choose two different angles, but you'll get the same answer, okay? Does that make sense? I mean, there's other ways to make 75 besides 45 and 30. But that's probably the easiest way to do it. So, what I'm going to do, let's rewrite this as a cosine of a 45 plus 30. And then I'm going to look at my notes. So if I look at my notes, I've got cosine of an angle plus an angle. So what I'm really going to use, cosine of theta plus 5. 45 plus 30. So I'm going to just use this formula here. So let me copy this formula down real quick. So the formula that I want to use is the one that goes cosine of theta cosine phi minus sine theta sine phi. Okay? And I know that because what I'm really trying to find is the cosine of two angles, right? Everybody okay on why I picked that one? Because a cosine of 45 plus, right? So in this case then, in my example, my theta is 45 and my phi is 30. Now stop me if you're confused. Hopefully this seems really easy. Yes, you're confused, but I'll help you out. Okay. You need to borrow my notes for a second, or look over Duncan's shoulder. Okay, and I'll get you that. And here's the reading, okay? All right, so let's take a look at it. So all I'm going to do, everybody okay on which formula I used, right? All I'm going to do is put 45 there and 30 there. I'm going to put 45 there and 30 there. So all I'm going to do is fill in the theta and the phi. So the answer, this is the same thing as cosine of 45, cosine of 30, minus sine of 45, sine of 30. So I'm just plugging the numbers, plugging the angles into the formula. That's all we're doing. Now, once we get that done, let's go to the unit circle, okay? Let's go to my unit circle, all right? So I look over, okay? So cosine of 45 has an answer, right? Cosine's the x value, right? So I'm instead of cosine of 45, I'm just going to write square root 2 over 2, okay? So we're going to write square root 2 over 2. Times, right? Cosine of 30, again, cosine is the x value. So cosine of 30 is square root of 3 over 2. Minus sine of 45, again, a look at the unit circle. Sine is the y value, which gives me a square root of 2 over 2, times sine of 30, if I look at the unit circle, is the y value, which is 1/2. Okay, now that's technically the answer, but let's tidy it up, okay? Now, it's not very hard to tidy it up. It's really going to be the square root of 6 over 4 minus the square root of 2 over 4, right? And since they both have a common denominator of 4, let's put them together for a grand answer. This is the exact answer. It would be the square root of 6 minus the square root of 2 over 4. That's my answer. All right. Now, cosine of pi 12. Sorry, now this gets a little harder because we have to think fractions. I know fractions are tough sometimes. But if I go to my unit circle, again, my unit circles, there's no 12ths, is there, right? There's no 12ths at all. So what I want to do is try and make something into 12ths. Now this could be, before you show it, 2 12ths, you okay with that? You okay with 2 12ths? You okay with 3 12ths? These fractions, 3 12ths, or usage. So let me write that down real quick. On the side, I think you're going to see where I'm going with this. On the side, I know that pi 6, little side, pi 6 could be the same thing as 2 pi 12. So I'm just, and the reason I'm changing it to 12s, so I need a 12 here, right? And I also know that pi 4ths is the same thing as 3 pi 12s, okay? Now how does that help me? Well, if I subtract this one from this one, right? If I go this, so if I do, let's see, if I rewrote this as cosine of 3 pi 12ths minus 2 pi 12ths, it would be the same as a cosine of pi 12ths. Okay, this one's a little harder because you have to be able to figure out fractions, right? But 3 12ths minus 2 12ths is a 1 12th, right? Everybody agree with that? So let me rewrite that. So this is really the same thing as cosine of pi 4ths minus pi 6, okay? So now I've got my phi and my theta. I really do. I've got my cosine of, this would be my theta, and that's my phi. So I look at my notes, look for cosine of theta minus phi, right? So look at my notes. I want this one, right? Okay, cosine of theta minus phi. Is that one right there? So let's go ahead and plug that in. So my formula turns out to be cosine theta cosine phi plus sine theta sine phi, okay? And I just have to plug them in. I've already established that theta is pi 4ths, phi is pi 6, so we're going to rewrite that as cosine of pi 4ths cosine of pi 6 plus sine pi 4ths sine pi 6. Okay, and then we're going to get our answer from the unit circle. So let's go to the unit circle. So go to the unit circle. Cosine of pi 4ths, cosine is the x value, square root of 2 over 2, so this is square root of 2 over 2. Cosine of pi 6, cosine is the x value, so square root of 3 over 2, plus sine of pi 4ths on the unit circle is square root of 2 over 2. Sine of pi 6, which is on the unit circle, y value is 1/2. So let's see what I get for a grand answer. Okay, how am I doing? Okay. We will have square root of 6 over 4 plus square root of 2 over 4, or the square root of 6 plus the square root of 2 over 4. There's my answer, okay?
Can you plus the square roots on the top end?
You can't because they're different square roots. I wish I could. Yeah, that'd be great if I could, but since they're different square roots, I can't. Good question, though. I can multiply them, but I can't add them. And Lane, a really easy example, which of course you'll get. If I've got x plus y, you can't do anything with that, right? But x times y, you can multiply those, right? And just make it xy, right? If they're different, you can't, okay? All right, now, if I take a look at this, it looks like it's a formula. Looks like it's a formula that's been already done, right? I see sine cosine plus cosine sine. Sine cosine, so I see kind of maybe sine theta cosine phi plus cosine theta sine phi, right? So that should match up. Sine cosine Sine, cosine, cosine, sine. I think it's that one right there, isn't it? Sine, cosine, plus cosine, sine. Sine, cosine, plus cosine. So it really came from sine of theta plus phi. Okay, I don't have these memorized, and I do not expect you guys to memorize them, okay? That's why we need our notes. So then, let's put in the phi's and put that in. So really, if that's theta and that's phi, right? The 20 is my theta, and my 40 is my phi, so then I'd really have something like a sine of 20 plus 40, right? Well, that's the same thing as sine of 60, and that's on the unit circle, isn't it? Okay, so if it's on the unit circle, 60 sine, which is the y value, is square root of 3 over 2. So the value of this is exactly the square root of 3 over 2, because we made it into sine of 60. So this one's kind of like going backwards. It's not bad, is it? Maybe the hardest one is the one with the pi's, because you had to think fractions, okay? Should we turn the page? Okay. All right, I am going to run out of time because of the bell, so I will leave these for another day, and I'll change the assignment, okay? Because I think we're going to be out of here in about 6 minutes. So let me go ahead and go to page 551, and I've got 4 to 20 even. Let's do this. Let's do 4 for sure. Let's do 10. And let's do 14. How's that? Just those 3. How's that? Easy? Yeah, you bet. Yeah. Okay.